Now so see here, for an, like there is a pair of semi conjugate diameters. Semi conjugate diameter means if these are conjugate diameters, then semi conjugate means half of them. So if I remove this part, then it becomes a pair of semi conjugate diameters, so half part, right, starting from the center of the ellipse, like this and this. So we, like, if you draw tangent at, suppose this is point A, this is point B, we draw tangent at A and we draw tangent at B. We have to find locus of point of intersection of tangents, these tangents, right? Let it be point P. I repeat this, these are EB, this CA and CB are two semi conjugate diameters. Now we draw tangents at their endpoints, that is, we draw tangent at A and tangent at B. Now these tangents are intersecting at point P. Now we're supposed to find locus of point P, right? The locus of point of intersection of tangents drawn at endpoints of pair of semi conjugate diameters, that is, tangents drawn at A and B, there is meeting at P, and we are supposed to find locus of P. So there are two approaches. Method one is, I write equation of tangent drawn at a point to an ellipse. So I assume this eccentric angle of A is theta and that of B is theta plus pi by 2. You know the relationship between the eccentric angles of A and B is a pi by 2 relationship. So you can just go and see in the theory. So equation of tangent drawn at A is x by A cos theta plus y by B sin theta equals to 1. Now this tangent is passing through point P. It means x1 y1 will satisfy this equation. So we replace x by x1 and y by y1, right? So it's a first relationship we have in changing parameter theta. Theta is changing, theta is a parameter, so we get first relationship. Similarly, we can write equation of tangent drawn at B. It is x by A cos of the eccentric angle, which is theta plus pi by 2, plus y by B sin theta plus pi by 2 equals to 1. It is minus x by A sin theta, because cos is negative in second quadrant, so minus, we get minus sin theta plus pi by 2 is cos theta equals to 1. This will also pass through point x1 y1, replace. So you can see we have two relationships in one changing parameter theta. First one is this and second one is this. We'll eliminate theta between the two. Now to eliminate theta, we can square and add, or square and add is something which you think is not easy to think of, it's not easy to come in mind. So you can solve these two for cos theta and sin theta. Like the way you solve two linear equations, solve for cos theta and sin theta, and once you have cos theta and sin theta, you know sin square plus cos square equal to 1. So square and add and equate it to 1, right? So if we, so in this case, like this, because of symmetry, we can say if we square and add, we'll get square of this, we'll add the square of this to form x1 square by a square into sin square theta plus cos square theta, that is 1. Same here, square and add, so we can take y1 square by b square, sin square plus cos square is 1. Now we'll have 2ab terms in both of them. We have 2ab term here, minus 2x1 y1 over ab cos theta sin theta, and here plus 2x1 y1 ab cos theta sin theta. Here we have minus 2x1 y1 ab by cos theta. So when we add the two, one is plus, other is minus, they are opposite signs, so they'll cancel out. If we add the xy term will cancel out. On this side we have 1, square and add, so it is 2. So locus is x square by a square plus y square by b square equals to 2, right? The alternate approach of this question can be, instead of writing equation of tangent, so just give you idea, you can finish alternate approach yourself, second method yourself. I write equation of AB as chord of contact. You know, equation of AB is chord of contact of the conic of the ellipse with respect to point P. It's a chord of contact with respect to point P. So equation is x1 by a square plus 5y1 by b square equals to 1. Now I can write equation of AB as chord. I can write equation of AB as chord whose eccentric angles of endpoints are theta and theta plus pi by 2. So you know x by a cos theta plus pi by 2 divided by 2 cos x by cos a plus z by 2 sin theta plus pi by 2 divided by 2 equals to cos a minus b, difference of the two angles. Difference of the two angles divided by 2 is cos pi by 4. So you can see I can assume this angle as alpha angle. This angle is also alpha angle. It is x by a cos alpha sin alpha equal to cos pi by 4 is 1 by root 2. Now I have this as equation of AB and I have this equation of AB. Now one line has two equations. How is this possible? They should be consonant to each other. So cos alpha by a x1 cos alpha by a divided by x1 by a square equals to sin alpha by b divided by y1 by b square equals to 1 by root 2. So cos alpha is x1 by root 2a and sin alpha is y1 by root 2b. Now square and add. If we take square and add, the left hand side will become 1, right hand side is x1 square by 2a square y1 square by 2b square. So we get the locus.